we're going to do a little bit of practice with bar graphs here and histograms. So this first one, we're talking about bachelor degree attainment by race. Is it reasonable to consider the skew of this bar graph? And this answer would be not really, because again, look at your data. You're using categorical data. So because it's categorical, we can't take white plus non-Hispanic white plus black plus Asian plus Hispanic and find an average. That doesn't work, right? You have to, and in order to really have skewness, we need to be able to compare the mean and the median. So this really just doesn't work for skewness. You can say, you know, it falls to the right, the less numbers on the right, but there's no, I mean, we could put blacks over here and then whites and then Hispanic, and it's not going to change the data, but it would change the shape of the graph, right? So we really need numbers down here going least to greatest in order to use skewness. Okay, why should the bars have equal width? And we've talked about this before, but it avoids bias. You don't want to draw any more attention to one graph than the other. The heights of the bars where they show frequency is what you want people to really look at. If we made this, you know, non-Hispanic white graph this wide, where the rest of them were just the same width, and you might say, well, now it's also red. Very true. But why is that graph so much, or that bar so much fatter, right? You're drawing attention to a graph for a different reason, where you really want the frequency or the height of the bars to be what your attention is drawn to, not the width. These two graphs, this one talks about the raw data. Here's the raw data. This one talks about percents. Okay, so we have raw data and we have percents. And why do you think these follow different patterns? If they're the same data, you know, why is the Asian bar so small down here, but it's the biggest one down here? And that's because when they figured out the rates, so let's pretend there were 80,000 whites, 60,000 non-Hispanic whites, 70,000, I am making these numbers up, 30,000, whatever. These are the totals, so then when you take the degree attainment, you're taking this frequency divided by this number, and you'll see the total for each one is different. So because the totals are different, when you divide, you're dividing by different denominators. That's what changes the graph. The only way your raw data and your percentage graph are going to be the same is if you're dividing by the same overall number. If we would divide each one of these by the same 100,000, that would create an identical graph. But if you're dividing by different numbers, that's what makes your graphs look different. When looking at this, could the total number of people that visited the testing center during the midterm week be estimated? And if so, how? And the key word here is estimated, and therefore the answer is yes. Because on Monday there were about 30. And on Tuesday there were about 40, and on Wednesday there were about 40, and on Thursday there were about 50, and there were about 70 on Friday, and maybe 60 on Thursday, right? That's an estimate. We could add those together to get an estimate of how many people. We would say 1, 2, what about 290? We're given that week, right? We could estimate based because of we were given the number of tests. We were given the frequency along the side. Now, how is midterm traffic distributed? Now, you can't necessarily say skewed left, skewed right, because again, we have categorical data. But you can, I mean, if we would assign these values, give each day a value, then you could do it. But the way they're written, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, you can't find the mean or the median of these datas. You could say later in the week is higher, because it shows Thursday, Friday, Saturdays where the majority of people came. But you can't use necessarily skewed left or right, because that is used for numerical data, not categorical. So unless you're going to recode this data to be numerical, you really can't use the skewness.